Okay, so this is section 4, which is finding the determinant of a square matrix. And so where do determinants become important? Well, for one thing, in physics, that is used. Also, there's some techniques for finding inverses of small matrices that use determinants. And I think we talk about that somewhere in here. Let me see if I can. Yeah, I don't see it, but anyway, there is a process you can use to find the inverse. Just looking to. Yeah, it's actually the next section. Okay, anyway. So when you have a matrix, the determinant is just a single number. And it does have some significance. It's not just something made up to confuse everybody. So we have problem number 10, which is 2, -3, -6, 9. So what is the determinant? Well, I usually show the determinant by doing these two vertical lines, and then you enter the numbers. And for a 2 by 2 matrix, you get a 2 by 2 determinant. And the process is you cross multiply these things, but this diagonal in this direction is negative, so it's going to be 2 times 9, the multiplication this way, and then subtract the other multiplication. It's -3 times -6. So 2 times 9 is 18, and then you're going to subtract 18. -3 times -6 is positive 18. So the final answer is 0. So the value, the determinant of that matrix is 0. Okay, 14, another 2 by 2 matrix. So you have 0, 6, -3, 2. So again, to find the determinant of that matrix, you write the same stuff, and you multiply in this direction, so you have 0 times 2 minus -3 times 6, so that'll be 0, and you have -18 times, change the sign, so you have positive 18. So that's the determinant of that. Okay, so we're going to skip over a lot of stuff here. So for larger matrices, like a 3 by 3, you have to do this thing about cofactors. And there's more than one way to solve the problem. So I'm going to do this one and show you that either way, there's actually probably, how many different ways could I do this? Probably 9 different ways or 8 different ways. I'm going to show you 2. To show you those 2 ways, give you the same answer. So the way it works is you create 3 2 by 2 determinants. So you have to choose either row or column kind of as your basis. So I'm going to choose, for the first case, I'm going to choose the first row. And the signs that you're going to use depend upon where you are in the matrix. So it's plus, just alternates. So you get plus, minus, plus, minus. So this one's going to be minus, plus, minus, plus, minus, plus. So it alternates this way, that way. You always have plus, minus, plus, or minus, plus, minus, plus, minus. So you take the first number, 1, which is in the list location, so it's plus 1. And then you multiply it by the determinant of the cofactor, which is, what you do is you mark through here, and you mark through there, and you're left with this 2 by 2. So you'd have 2, 0, 4, 3. Okay, so let me go ahead and move these out of the way. Okay, then you take the next number in this row, which is 4, and it's going to have a negative sign. So you'll have -4. And then, again, you mark through the row and the column associated with that entry. That leaves these 4 numbers left. So that's the 2x2 determinant that results from that crossing out stuff. So you end up with 3, 0, -1, 3. And then you go to the last number in that row. So that's going to be -2. Okay, so we're going to plus, I guess I'll put a plus, but it's -2. So that's that number. Again, this is the row it's in, this is the column it's in, this is the smaller matrix, and you find the determinant of that matrix. Okay, so you have 3 parts. The coefficients involve a particular row or column. And then when you cross out the row and the column, what's left over is the numbers that create this. Okay, so now we take 1 and we multiply by the determinant of this, which is going to be 2 times 3 is 6, minus 0 times 4, which is 0. Then you have -4. So here you have 3 times 3, which is 9. And then you subtract 0 times -1, which is 0. And then you have -2. And the determinant is going to be 4 times 3 times 4, which is 12. And then you subtract the product of these two, which is -2. So you got to be really careful about signs here, because you're subtracting this, but then there may be a case where you have a negative sign. So here we have 6 times 1, so that's 6. Here we have 9 times -4, so that's -36. And here we'll have 12 plus 2, which is 14. 14 times -2 is -28. So if you do the math there, 6 minus 36 minus 28 is -58. So it says the determinant of this is -58. Okay, now we're going to do it one more way. You don't have to do it 2 ways. I'm just proving that it doesn't matter which one you choose. Okay, what I'm going to do is I'm going to do it using these 4 numbers. I'm going to choose the second column. Okay, so you start up here with the top, or you can start at the bottom, it doesn't matter. So we write 4 down, that's the multiplying factor. It's negative. And then you cross out the row and the column that thing is in. So that leaves these remaining numbers, 3, 0, -1, 3. Okay, let's move this, delete those. Okay, then we go to the next number, 2. So that's going to be the multiplier. 2, cross out the row and the column. So we got 1, -2, -1, 3. Then finally we come down and we pick up the last number, which is 4, but it's going to be negative. So it's -4. And we have this determinant. So let's mark through the row and the column that this is in. That leaves the numbers 1, -2, 3, and 0. Okay. So we have -4 times 3 times 3 is 9. that's 0, plus 2 times 1 times 3 is 3, and then we have 2 times negative 2 times negative 1 is positive 2, but we subtract that, and then we have minus 4 times 1. Then we have, so we have 1, or actually 1 times 0, which is 0, and 3 times 2 is negative 6. We subtract that part, so it's going to be a negative of a negative 6. So let me just put that in there. So it's negative 6. Okay, so here we have minus 36, 9 times negative 4. Here we have 3 minus 2, which is 1. 1 times 2 is 2. And then finally we have positive 6 times negative 4, which is negative 24. We plug that into our calculator. Negative 36 plus 2 minus 24, negative 58. That's exactly what we got here. So that's how it works. Okay, the next problem is 46. So I'm just going to do it one way this time. So we've got 3, 0, 0, 7, 11, 0, 1, 2, 2. Now, in this case, sometimes it makes sense to choose either a particular row or a particular column that has the most zeros in. So in this case, we could either choose first row or the last column. Well, we've done the first row first, so let's do the last column just to be different. So these are the numbers I'm going to do. And the reason it's easier is because 2 of the terms are going to go to 0. So I start here. Let's bring over I need to bring this over. Because I don't need to, but I'm doing this to help you out. Okay. So here's the sign. So this is positive, so it's going to be positive 0 times, doesn't really matter, but it would be, let's not get too flippant here. So what you'd have left is 7, 11, 1, and 2, but because it's multiplied by 0, it's not going to really make anything difference in the long term. Okay. But just so you know the procedure. Okay, second part, minus, because this term here, minus 0 times. So you take that and you mark out these two. That leaves negative 3, 0, 1, and 2. Of course, those both are going to be 0. And then you have the third one, which is the last thing, which is the only one that actually counts here. So you take this row and this column, the coefficient is 2, it's positive, so we have plus 2 times, and then the matrix, and actually it should be the determinants because I'm not doing this perfectly, right? So you get 3, 0, negative 3, 0, 7, 11. So you get 0 minus 0 plus 2 times. So you have negative 33 and 0. So that's just negative 33. So the final answer, just have to multiply two numbers together, which is negative 66. I'm just going to double check. So that's 8, 4, 46. So that's negative 66. Okay. So I got that one. And then 48. So that's a 4 by 4. Okay. 3, 6, -5, 4, -2, 0, 6, 0, 1, 1, 2, 2, 0, 3, -1, -1. Okay. So this one you actually have to go through it twice. Okay, so what we're going to do is first you want to pick a row that has the most number of zeros, which is this one. So we're going to do this. We're going to do this row right here, or column. But that's the only row or column that has 2 zeros in it. So you take the coefficient. Now you always start with plus here. So this is going to be plus minus. So it's going to be minus. It's going to be minus a -2. And then what you've got left over when you mark through the row and the column is you end up with a 3 by 3 matrix. So you get 6, -5, 4, 1, 2, 2, 3, -1, -1. Okay. This one's going to be 0, so we don't have to worry about it. Now we do this one. So that's also going to be negative because it's positive, negative, positive, negative. So that's going to be -6 times. So again, we mark through this row and this column. And what's left is 3, 6, 4, 1, 1, 2, 0, 3, -1. Okay, now we have to do it again on these matrices. So what I'm going to do is we're just going to do these separately. And then once we get a number, we can multiply everything out. So it really doesn't matter in this case which row I'm going to choose. I'm going to just choose the first row because that's the easiest thing to do. So we're going to use this row right there. So this is equal to 6, and so you actually don't have to physically mark these out. What you do is you think that and you mark that out, and what you have left is 2, 2, -1, -1. Okay, so that's this remaining. Then you subtract the next one because it's in the next position over. Subtract -5, and if you cross this out and cross that out, you're left with these 4. So it's 1, 2, 3, -1. So again, cross that out, cross that out. If you need to do it, just do that. You get 1, 2, 3, -1. And then finally, you take this number, which is positive now. Positive. It's positive, but it's also positive because of where it is in the determinant. And then you multiply. So if you cross this out and that out, you're left with this 4, which is 1, 2, 3, -1. Okay, so now we can just use the cross product thing. So you have 6, you get -2 minus -2, that's going to be 0. Then you have +5 times -1 minus 6. So -1 minus 6 plus 4 times -1 -1 minus 6. So that's going to be -7 times 5 is -35, plus, then you have 4 times -7, which is negative. So that's going to be -7 times 4, -28. Add those together, you get -63. Okay, so that's what we can do is let's go ahead and just put it in there. So you get 2, negative 2 times positive 2. Negative 2 times negative 2 is positive 2. That is equal to negative 63. Okay, then we're going to have minus 6 times the next part. So let me go ahead and add a page here. So we do the second matrix, which is 3, 6, 4, 1, 1, 2, 0, 3, negative 1. So I'm going to choose the first column because that has a 0 in it. So that means I have to do one less calculation. So I take this number 3, which is positive because it's up the upper left-hand corner is always positive. And if I cross out this and I cross out that, I'm left with 1, 2, 3, negative 1. So you take this times that 1. Then you'll have minus 1. It's negative because it's the next one down. And then you multiply. If I cross this out and cross that out, cross this one, cross that one, I get 6, 4, 3, negative 1. 6, 4, 3, negative 1. So the first determinant is negative 1 minus 6. The second is going to be negative 6 minus 12. So 6 times negative 1 is negative 6. 3 times 4 is 12, but you subtract it. So here we have negative 7 times 3, which is negative 21. Here we have negative 18 times negative 1, so that's positive 18. So you add those two together, negative 3. So that's the value for this thing. So we plug that in, negative 3 into there. And so the final answer is going to be 2 times negative 63 plus 18, which is negative 108. So let's double check this. This is 48. 48, section 8.4. Negative 108. Okay. And our final problem in this section is 63. So it says find the determinant of A, determinant of B, A times B, and the determinant of A times B. Okay. (63). So A is 4, 0, 3, negative 2. B matrix is negative 1, 1, negative 2, 2. So the determinant of A is this, which is just equal to 4 times negative 2, which is negative 8, minus 3 times 0, which is 0, so that's negative 8. The determinant of B it's going to be negative 1 times negative 1 times 2, which is negative 2. You're going to subtract negative 2 times 1, which is negative 2. So negative 2 plus 2 is 0. So that's the determinant of B. Okay, third problem is what is AB, which is just A times B. So what we have is A was 4, 0, 3, negative 2. B is negative 1, 1, negative 2, 2. And the way we should end up with a 4 by 4 matrix. So the entry up here is 4 times negative 1, which is negative 4, plus this, which is 0, so it's negative 4. this entry is this times first row times the second column, so you have 4 times 1 plus 0 times 2, so that's 4. This entry is this row in this column, so you get negative 3 plus 4, that's going to be negative 1. And then the final corner is the second row, second column. So you get 3 times 1, which is 3, and negative 2 times 2, which is negative 4. 3 minus 4 is negative 1. So that's A times B. And then they want the determinant of that. So that's going to be negative 4 times negative 1, which is positive 4, and then you subtract 4 times negative 1, which is negative 4, and so that is 8. So that's the determinant of that. So let's check out the answer. So that's 63. Negative 8, correct. 0, correct. Negative 4, 4, 1, negative 1. Must have done a math error there. Let me try that out. So it's this one. Negative 3 plus 4. Okay, yep, that's plus 1. Okay. 3 times negative 1 is negative 3. This is plus 4. It should be plus 1. So let's go back over here. Change that to plus 1. I think the answer is going to be 0. Okay. Negative 4 times negative 1 is 4. You subtract 4, you get 0. So the answer should be 0 for the last one. Okay. That's all.